Hello everybody, welcome into another lesson and the very final lesson of the conic sections unit. So today we are going to solve systems of quadratic equations where you have three equations. And again, the goal is going to be to figure out this time where three conic sections intersect, if they even do at all. So here you have x squared plus y squared plus 8x plus 7 equals 0. X squared plus y squared plus 4x minus 4y minus 5 equals 0. And then you have x squared plus y squared equals 1. All three of these are equations of a circle. What I would do before we do any type of elimination, move your constant terms out of the left-hand side. So what does that look like? This is all going to turn into x squared plus y squared plus 8x equals negative 7. Then you'll have x squared plus y squared plus 4x minus 4y equals 5. Then you'll have x squared plus y squared equals 1. So that's something much easier to work with. Now, in this case, we definitely need to use elimination. So let's get some equations here. If we take, let's deal with the first and third equation. So if we take x squared plus y squared plus 8x equal to negative 7, and then we take x squared plus y squared equals 1. Man, I'm missing stuff here. If we subtract the third equation from the first here, notice right away you can eliminate your x squared and y squared. You drop down to a simple linear equation. You would have 8x equals negative 8. Thus, you already got your x value. X equals negative 1. Alright, now, we also need to find another equation by, let's say we combine the second and the third one. So let's do elimination with the second and third one. So we'll take x squared plus y squared plus 4x minus 4y equals 5. And then we'll have x squared plus y squared equals 1. So if we use elimination, again, notice we can eliminate the quadratic terms. You'll just end up having 4x minus 4y is equal to 4. Alright, so let's go ahead now and put in that x value of negative 1. So you would end up getting negative 4 minus 4y equals 4, which would give you negative 4y equals 8, which would look like y equals negative 2. But here's the caveat with this. It looks like we have a point of intersection, but stick these x and y values into even one of your equations. Stick them both in to see if it even holds up, if it works. So let's put that negative 1 in for the x squared plus y squared equals 1. So you would end up getting negative 1 squared plus your y value of negative 2 squared. Set that equal to 1. Well, you get 1 plus 4 equals 1, which would be like saying 5 equals 1. We know that's not true. 5 does not equal 1. So there's no solution, because if it doesn't work for even one of the equations, then there's no solution. So if you have all three equations quadratic, you very well could end up having where you have one of them doesn't have a solution. And the idea was to figure out where all three of these circles intersect, and clearly they don't because there's no solution. So there's that one. I have another one like this, then I have two more after it. All right. Now, let's see here. So we have x squared plus y squared minus 8 equals 0. X squared plus y squared minus 3x plus y equals 0. Now we have 2x squared plus 2y squared minus 5x. Is that minus 10? Yes, minus 10 equals 0. Alright, so we have x squared plus y squared minus 8 equals 0. X squared plus y squared minus 3x plus y equals 0. 2x squared plus 2y squared minus 5x minus 10 equals 0. Well, we clearly again have three circles here, three equations of circles. It's our job to try to figure out, first of all, do they intersect? And second of all, if so, where do they intersect? So, like the last one, I'm going to recommend you get rid of any constant terms out of the left-hand side and move them over to the right. So this would turn into x squared plus y squared equals 8. Then this would turn into x squared plus y squared minus 3xy plus y equals 0. That second one hasn't changed. Then you'll have the third equation of 2x squared plus 2y squared minus 5x equals 10. So now we got the constants out of the left-hand side and on the right-hand side. That'll make life a little bit easier. Now, we're going to have to use elimination again. So let's start with the first and second one. If we deal with the first and second, so you'll have x squared plus y squared equals 8, and then you'll have x squared plus y squared minus 3x plus y equals 0. So if you subtract the second equation from the first, notice your quadratic terms are gone. This would turn into 3x minus y equals 8. Much easier to work with now, isn't it? 3x minus y equals 8. Okay, and then let's deal with the first and third this time. So this would become x squared plus y squared equals 8. And then you'll have 2x squared plus 2y squared minus 5x equals 10. Alright, so this now would end up being, we want to use elimination again. Well, what I'm going to suggest is we multiply the first equation by 2 so we can eliminate our quadratic term. So the first equation will become 2x squared plus 2y squared equals 16. Then you'll still have 2x squared plus 2y squared minus 5x equals 10. Now we can subtract the second equation here from the first one. Your x squareds and y squareds are gone. You end up getting positive 5x equals 6. Notice you have 5x equals 6. So that's going to give you then, of course, x equals 6/5. And then it would look like you're going to put that 6/5 in here and solve. So you'll take 3 times 6/5 minus y equals 8, which would end up giving you 18/5 minus y equals 8. All right. So what is 8 in terms of a denominator of 5? That's 40. You would end up getting y equals negative 22/5. All right. So far it looks like we got two good solutions here, right, for one ordered pair. But again, when all three equations are quadratic, you need to pick an equation and stick that in. Stick both the x and y values in, see if it holds up. So let's put it into x squared plus y squared equals 8. So x was 6/5, so this is going to be saying 6/5 to the second power plus negative 22/5 to the second power equals 8. Well, 6/5 is 36/25, plus now we have 22 to the second over 5, which is 484 over 25. That'd be saying that equals 8. 490, so that'd be saying then 520 over 25 equals 8. Well, it definitely doesn't, because 200 over 25 equals 8. So they're not equal. So in other words, you also have no solution to this one. It doesn't hold up in the first equation. And if these x and y values don't hold up in even one of them, then there's no solution, because the idea of finding a solution is where do all three of these circles intersect? And they clearly don't, since there's actually no solution. I got just two more, then we're done. All right, now, here's a good one. So we have x squared plus 3y squared is equal to 16. Then we have 3x squared plus y squared is also equal to 16. All right, and then we also are given that y equals negative x. So you do have three equations here again. You have x squared plus 3y squared equals 16, which is the equation of an ellipse. You also have 3x squared plus y squared equals 16. That's another ellipse. Then you just got y equals negative x, which is a line. So we need to figure out if these two ellipses and a line intersect anywhere, and if so, where all three would intersect. So when you have a linear equation and then two quadratics, you can almost treat that y equals negative x as an identity, which is going to make your life easier. But first, you want to use elimination on the first two equations. So you're going to use both elimination and substitution to solve this. So let's deal with the first two equations. So x squared plus 3y squared equals 16, and then 3x squared plus y squared equals 16. I'm going to say we multiply the second equation by 3 so we can try to eliminate the y variable. So keep your x squared plus your 3y squared equal to 16, but multiply your second equation by 3. You'll end up getting 9x squared plus 3y squared is equal to 48. All right, so then you subtract the second equation from the first, you'll end up getting negative 8x squared. Your y squareds are gone. That would just equal negative 32. Which then is going to tell you that x squared equals positive 4, and then x equals plus and minus 2. All right. So x equals both plus and minus 2. Now we have y equals negative x. So if we take our first value of x, the negative 2, that means y would equal negative 2, which would equal positive 2. And then if we take, for our second value of x would be positive 2, that means y would simply equal negative 2. But we need to test this theory in at least one of the other equations here. We know it works in y equals negative x. Let's test it in one of these two equations to see if it works. So let's take your first ordered pair. So x1, we'll take negative 2 to the second power plus 3 times your positive 2 to the second power. Set that equal to 16, which would end up turning into 4 plus 3 times 4 equal to 16, which would also end up then turning into 4 plus 12 equals 16. Well, 16 equals 16. You have a true statement. So the ordered pair negative 2, positive 2 is definitely a viable solution. Now, let's check our second coordinates. Why don't we put these into the second equation? So if we take 3 times that x2 of 2 to the second power plus our y of negative 2 to the second power, set that equal to 16, you'll end up getting 3 times 4 plus 4 equals 16, which would give you 12 plus 4 equals 16, and 16 equals 16. So that means your ordered pair 2, negative 2 also works. So the two ordered pairs that are the solution to this system are negative 2, 2, and then positive 2, negative 2. That's where these two ellipses and the line would all intersect at both of those 2 points. And I got just one more and we are done. Alright, what's the last one look like? X squared plus y squared minus 4x minus 4y equals 26. Then we have x squared plus y squared minus 4x equals 54. And then we've been given y equals 3x minus 8. Alright, so we have x squared plus y squared minus 4x minus 4y equals 26. We have x squared plus y squared minus 4x equals 54, and then y equals 3x minus 8. So this is going to be the first two equations are circles, the last one's a line. So we need to figure out where these two circles and a line intersect, if at all. So again, you have a linear equation, so I would use that as an identity. So let's take the first equation and the second equation, use elimination. So it's going to be another problem we use both elimination and substitution. So take the first equation, x squared plus y squared minus 4x minus 4y equals 26. And then you'll also take x squared plus y squared minus 4x equals 54. So subtract that second equation from the first. Notice your x squareds and y squareds are gone, and actually so are your x to the first. So all you would literally have is negative 4y equals negative 28, which would give you y equals 7. Now, you can put that y value of 7 into the linear equation. So that would give you 3x minus 8 equals 7, which would give you 3x equals 15, which would give you x equals 5. But it's probably a good idea to test these two numbers in at least one of the equations to make sure it holds up. Let's do it in the top one. So the x was 5, so this will be 5 squared plus that y squared, so that'd be plus 7 squared minus 4 times 5 minus 4 times 7 equals 26. So this would end up being 25 plus 49 minus 20 minus 28 equal to 26. All right, so 25 plus 49, that's going to be 74, minus 20 is 54, minus 28 equals 26. So you actually get 26 equals 26. So yes, your ordered pair, that's the solution, is going to be the 0.57. So 57 is where all three of these come together. So that is it for conic sections. The next lesson we are starting a brand new unit, which is going to be about sequences and series. The very next lesson will be an introduction to sequences. So I hope everyone has a great day. Take care.